The future of AI is tiny. I welcome you all to this seminar on tiny and green AI. I am Yoshi Bansal. I am BTech CSE third year student at Bennett University. This university is located in Greater Noida, and in this session we will learn about tiny AI. So let's begin the session, guys. Taking a look on the agenda for this session, I'm gonna start with what exactly is AI/ML, and moving further, I will discuss what tiny means, applications of tiny AI, how to implement tiny AI, tiny ML in industry, tiny ML in environment. Then we will see some real world examples, and moving further, we discuss what is green AI, and to sum up the session, I will point some challenges of tiny AI. So without any further ado, let's begin our session. What AI is, and let's understand some technologies and start with AI. Building smart machines capable of performing tasks that typically require human intelligence are known as artificial intelligence, okay, or AI. On the other hand, ML is a subfield of AI focused on developing algorithms that learn to solve problems by analyzing data for patterns. Whosoever programmer and attending this session knows that in case of traditional programming, we write the code that takes the data and then apply some functions to it, which is known as program, right? But in ML, we give the data, like we give input and we give desired output as well to the algorithm, and it learns the mapping between the input and the output by itself. So basically, your program is written by the computer itself. ML is increasingly moving from cloud to endpoint devices. Now let's talk about what tiny means. Tiny machine learning or tiny ML is a fast growing field of machine learning technologies and applications, including algorithms, hardware, and softwares that are capable of performing on device sensor data analysis. These sensor data includes vision, audio, IMU, biomedical, etc. These algorithms can run at extremely low power, typically in a microwatt range and even below, and hence enable a variety of always-on use cases and targeting battery-operated devices. So basically, running AI on microcontrollers makes tiny AI. You can find microcontrollers in every device. For example, your iron, coffee maker, and many more places. Now the question is, can you make them smart by putting TinyML on top of it? These devices are going to increase in quantity. These devices are very cheap and consumes very less power, and they are small. They can run for months, years on these small little batteries. Uh, Combination of both ML and embedded system results in tiny ML. An embedded system is a combination of computer hardware and software designed for a specific function. Now, how ML can enable new and interesting tiny ML applications? What are the challenges with enabling ML on tiny resource constrained embedded devices? What type of new use cases can be possible enabling on embedded system that we could not otherwise do before? Some of the applications of tiny ML are autonomous drones, mobile robots, smart glasses, taking care of wildlife and forest, improving quality of oceans, keeping an eye on melting ice caps. And not only these, any application which needs real-time machine learning, on the edge tag, on the spot decision, real-time data collection and suggestions can be solved using TinyML. There are medical use cases as well. Now, how we can implement tiny AI? Before implementing tiny AI, we have to also keep in mind that what problem we are solving. How complicated is the running task? How much memory does it need to have? How long does the job have to perform? After these three questions, Now we have to think about reducing the size of the model and how to squeeze big ML model. It's all about how well can we shrink or compress the model down without losing its ability to fundamentally find the patterns in data. Some model compression techniques include pruning, quantization, knowledge distillation, and there are many more. Now, the softwares that we use in achieving TinyML are TensorFlow Lite Micro. It's a great framework of TensorFlow, and TensorFlow is the Google product, right? Now these are like we use hardware as well, like Arduino Nano, and lots of sensors. Know what's the process. Now basically the life cycle of the ML is quite similar. Okay, so we used to like collect the data. We start with collecting the data, we process the data, design a model, train a model, and then convert a model. Now after that, for basically for specifically TinyML, to achieving TinyML, we optimize the model, and then we deploy models on edge. Now these edge devices can be iOS, can be Linux, can be Android, and even microcontrollers. Okay, these like have you like converting model is in case of TensorFlow, we convert the model in .tf like file. Okay, and after the deploying model on edge, we run the inference on the edge. Okay, now let's see some applications in industry. Okay, anomaly detection mechanism. I'm taking the example of anomaly detection mechanism. For instance, like detecting sounds or behavior pattern of the machine. If something is about to go wrong, these machines gives little hints and clues in the vibration they make and sounds that they emitting. And by observing these things in real time, right at the end point through TinyML, we can figure out if the machine is going to break or not. Okay, so there are many pros to this. We can actually reduce the downtime for repair, increase efficiency. These are very cost effective and increase the productivity. Now there are some cons. Okay, for example, accuracy, balancing missed detections and fall alarms, right? Explainability, can operate respond to alarms effectively, and they can explain why this alarm triggered, right? And how will this affect the organization's workflow. Okay, now let's talk the TinyML in environment. Biodiversity actually is declining at a rapid pace, and several wild species are at risk of extinction. Using TinyML, we can monitor animals' movements and behavior. Okay, some of the pros to this is more we will have more detailed insights, as these devices are on the spot, right? So we have more detailed insights, less data wastage. These are very cost effective and overcome limitations of human labor. There are some serious concerns to this too. Uh, that are, is data reliable? Who can access the data? And can device be hacked by poachers? Okay, so these are some serious concerns, and you can also call them cons. Now let's talk about one interesting case study of elephant edge, and this is the challenge of building the world's most advanced wildlife tracker. It includes risk monitoring, conflict monitoring, activity monitoring, and communication monitoring. Now, in risk monitoring, it know when an elephant is moving into high risk area and send real time notification to park rangers. Conflict monitoring sends an alert when an elephant is heading into area where farmers live. Activity monitoring classify the general behavior of the elephant, such as when it is drinking, eating, sleeping, playing, etc. etc. Communication monitoring listen for vocal communication between elephants via onboard microphone. It's a great challenge. You can actually go and check this on Google, right? Let's talk about green AI. Okay, GPU is a major contributor to the heat, and running AI model requires a lot of processing that is delivered by these GPUs. Today, AI is used in every field: research, education, banking, medical, finance, manufacturing, and many more. And as we follow the trends, use of AI will increase, and with increase of AI applications, we will damage our environment, and this is something that need to be solved. So green AI suggests to build models which consumes less energy, memory, as well as require less space, so that we can have as less carbon footprint as possible to the environment, while do not compromising with the uh, developing humans, right? So with the techniques of TinyML, we can achieve this and can run inferences on the edge devices for months as well as sometimes for years. So this is what green AI is. Now there are some serious challenges to tiny AI, and running model on embedded devices is quite a difficult job when you have to maintain the accuracy while optimizing the model at the same time. These embedded systems are designed for a specific task. Therefore, general intelligence is not possible till date. And we know that AI requires lots and lots of processing, memory, and storing weights of these models take a huge amount of space. Therefore, running them onto devices which are highly resource constrained is quite challenging. Remember that AI is not always the best solution. Choose wisely between traditional programming and machine learning. And this actually brings us to the end of the session. Hope you learned something today. If you have any questions, feel free to comment, and thank you.